Marina?
ഷെറിൻ, ഞാനിപ്പോ സിസ്റ്ററിനോട്
സിസ്റ്ററും കൂടെ കേറിയിട്ട് ഇവരെ കയറ്റിയാ മതിയോ?
ആരാ?
സിസ്റ്ററിനെയും കൂടെ കയറ്റിയിട്ട് ലിങ്ക് പോയാ മതിയോ?
വിട്ടോ.
വിട്ടേക്കട്ടെ. ഓക്കെ.
പിന്നെ ഒരു കാര്യം കൂടെ, ഗായത്രിയുടെ ഷെറിൻ നോക്കിയല്ലോ അല്ലേ സംഭവങ്ങള്?
നോക്കിയായിരുന്നു.
പ്രോഗ്രാമിന്റെ സ്ട്രക്ചറും എല്ലാം നോക്കിയതല്ലേ? കുഴപ്പമില്ലല്ലോ?
കുഴപ്പമില്ല.
ശരിടാ. അപ്പൊ സൈലന്റ് പ്രെയർ ആണല്ലോ അല്ലേ?
ടോപ്പിക്കിന്റെ പേരെന്ന് പറഞ്ഞാൽ ലുക്കിംഗ് അറ്റ് ദി ഓഷ്യൻ
ഫ്രം സ്പേസ്. അപ്പം ഇതിന്റെ നമ്മുടെ സ്ലൈഡ് വരണ്ടേ ഇതില്?
ആയിട്ടേക്കട്ടെ. എനിക്ക് കേറാൻ പറ്റത്തില്ല. മെറീന ഏതില്ല?
ഞാന് പ്രസന്ന വിടണോ? ഞാൻ
കൊടുക്കാവോ?
കൊടുക്കാം. എനിക്ക് പ്രസന്ന വിട്ടോണ്ട്
ഞാന് ഫോണിൽ നിന്നാണേ.
ഞാൻ ചെയ്തോളാം.
പ്രസന്റേഷൻ ഇല്ലേ, മെയിൽ അയച്ചില്ലേ? ഇന്നലെ അയച്ചില്ലേ?
അതാണല്ലേ? ഒരു മിനിറ്റ്. പ്രസന്ന വിടുമ്പോഴേ എന്റെ സ്ക്രീനല്ലേ ഷെയർ ചെയ്ത് പോകുന്നേ? അപ്പൊ ഒരു ചെറിയ ഇഷ്യൂ ഇല്ലേ എനിക്ക് പ്രസംഗം? ഷെറിൻ, ആ മെയില് പുറത്തുണ്ട്. വിധു
നോക്കട്ടെ, ഞാൻ ഒന്നുകൂടെ കയറാൻ നോക്കാം.
പ്രശ്നം ഉണ്ടാവുകയാണെങ്കിൽ ജോസ്ലിനോ വിധുവോ അതൊന്ന് പ്രസന്നോ ഇട്ടാ മതി. ഞാൻ മെയില് ഫോർവേഡ് ചെയ്ത് തരാം.
മെയിലാണോ ചേച്ചി?
ഞാൻ മെയിലില് ഒരു PPT ഉണ്ട് ഷെറിൻ ഉണ്ടാക്കിയത്. അത് ഞാൻ ഫോർവേഡ് ചെയ്ത് ഇടാം.
അത് മതി.
അപ്പം അതിൽ നിന്ന് ഒന്ന് പ്രസന്റ് ചെയ്താൽ മതി. എനിക്ക് പ്രസംഗം ഞാൻ മെയിൽ ചെയ്തിട്ടുണ്ടേ.
വിധു ഞാൻ പ്രസന്റ് നൗ കൊടുത്തേ.
ഷെറിൻ മീറ്റ് URL പോകുന്നില്ലേ?
ഹലോ
ഷെറിൻ
കേക്കാലോ അല്ലേ?
കേക്കാം.
ടീം കാണാവോ? കാണാലോ.
കാണാം.
മെയില് പോയിട്ടുണ്ടേ.
ഓക്കെ ഫൈൻ. Now let's mute.
Okay.
Good evening, all. A very warm welcome to each and everyone who intended to spend their valuable time as one among us and lend their hand to support our venture. First of all, let's start the ceremony with a silent prayer. Initiatives are a must for a strong future. With this perspective, UN's General Assembly proclaimed World Space Week in 1999 to celebrate the contributions of space science and technology to the betterment of human condition. Underlying this path of vision, UN intended to celebrate the world's largest annual space event this year from 4th October to 10th October on the topic Satellite Improves Life. Irrespective of current scenario, Ascension College Autonomous has intended to conduct this international webinar on the topic Looking at the Ocean from Space. Now, to enlist more possible outcomes and to welcome all the profound personalities gathered here, I welcome Dr. Marina Aloysius, HOD of Research and PG Department of Physics, Assumption College, Changanasheri, for the welcome speech.
Thank you, Gayatri. Very respected principal of our college, Sister Cherugusuman CMC, Vice Principals, Reverend Father Thomas Joseph Paratara, and Dr. Anita Jose, the most distinguished resource person of the day, Dr. Korak Saha, Coordinator of the program, Dr. Sharon Thomas, Student Coordinator, Ms. Asmi Sibi, and all other distinguished participants gathered here. Good afternoon, all. Am I audible? Okay.
Yes, Marina.
Why do we think of space when there are so many problems on Earth which are to be fixed up? This is a very rational question which many of us ask. And the short answer is that we need to go to space to help us hear many things on Earth. Yes, since Sputnik, the world's first artificial satellite, was successfully launched in 1957, space exploration accelerated in amazing pace, and now we have reached the heights humanity never have dreamt. In this context, World Space Week celebrations become very relevant. And the theme chosen for this year's celebrations, Satellites Improve Life, is really significant. While we may not always realize or acknowledge the existence of satellites, the role played by them to the betterment of humanity should never be underestimated. This is the best time we can think, learn, and celebrate the contributions of satellite technology to mankind. Today, when the whole world celebrates the anniversary of space exploration, the Research and Postgraduate Department of Physics of Assumption College join hands with the global community to celebrate this occasion. With this introduction, let me move on with the duty of welcoming each one present here. We are so much honored to have the presence of our principal, Mr. Cherugusuman CLC, in this event. And she is a strong supporter of all our engineers and have agreed to bless and inaugurate our program. On behalf of our department and all who have gathered here, I extend a warm welcome, dear sister. I take this opportunity to welcome our dearest vice principals, Reverend Father Thomas Joseph Paratara and Dr. Anita Jose, who inspires us all through. And as the resource person of the day, we have with us an expert in the field of space science and a person very eminent to talk on the theme particularly. He did his graduation and post-graduation in Punjab University and was selected for the Junior Research Fellowship in Indian Space Research Organization in 2003. And under this fellowship, he worked in Space Physics Laboratory, Vikram Sarabhai Space Center, Trivandrum, and was awarded PhD from Cochin University of Science and Technology in 2009. His research thesis deals with atmospheric correction techniques in the GPS signal for aircraft navigation and water vapor estimation as part of the GPS-aided Geo-Augmented Navigation Program, which is known as GAGAN, under Government of India. He has also worked in the Indo-French climate satellite Megatropics. And later he continued his career in US at Nova Nesdis Star as Colorado State University Cooperative Institute postdoctoral scientist from 2010 to 2014. And since 2014, he works as a research scientist with Nova Nesdis NCEI, University of Maryland, USA. And his works involves generation, validation, and archival of oceanographic data related to climate studies. With his immense knowledge and expertise in the field of satellite remote sensing, he is one among the best to speak on the topic of this year's World Space Week theme. I am indeed very proud to say that he is one of my close friends, and with immense pleasure and love, on behalf of the Assumption College and all who have gathered here, I proudly welcome the young charismatic resource person of the day, Dr. Korak Saha. The faculty coordinator of the program, Dr. Sharon Thomas, has been behind coordinating the program for many days. With immense pleasure, I wholeheartedly welcome my smart colleague, Dr. Sharon Thomas, and all other dynamic colleagues of my department to this auspicious occasion. Let me also welcome the student coordinator, Ms. Asmi Sibi, and all other students who have been behind the curtains for making the arrangements for today's program. And it is wonderful to see such an amazing gathering here today. We are so much honored to have the presence of our dear students and the students and teachers from various other institutions and our well-wishers all over India and outside. We extend most hearty welcome to all dear participants who are here to make the webinar enriching. With this, invoking the blessings of God, let me conclude. Wishing you a fruitful session. Thank you.
Thank you so much, Miss. Now, moving on to the official inauguration of this event, I welcome Sister Cherukusuman CNC, the very respected principal of Assumption College, Changanasheri, for the inaugural address.
Good afternoon to all. Respected resource person Dr. Korak Saha, dear colleagues, and my dear participants. In this week, October 4th, 10th, we celebrate the World Space Week 2020. The Space Week helps to build up the workforce of tomorrow by inspiring students, demonstrates visible public support for the space program, educates the public about space activities, and fosters international cooperation in space outreach and education. I am very happy to know that the Research and PhD Department of Physics of Assumption College is organizing an international webinar, and the theme of the webinar is Satellites Improve Life. I am sure that the expertism of the resource person will definitely enhance the knowledge of the participants in this particular area. The quiz competition is a chance to evaluate and improve the participants' their knowledge in space science. I congratulate the Department of Physics for their interest and efforts to organize this webinar. I wish success to today's webinar and the participants an enriching session. I declare today's international webinar open. Thank you.
Thank you so much, sister. Knowledge shines most on the way it's presented. Having a professional resource person who is supreme understanding study is a blessing. Now, we have with us the very experienced research scientist who is highly skilled in remote sensing, physical oceanography, marine ecology, land emissivity, and many more. Along with it, he holds a doctoral philosophy focused in atmospheric physics and microwave remote sensing from KUSAT. I proudly welcome Dr. Korak Saha, Assistant Research Scientist, National Oceanic and Atmospheric Administration, NCI, and ESSIC, Cooperative Institute for Satellite Earth System Studies, University of Maryland, USA, to take over this function.
Hello. Thank you very much for those kind words, especially Gayatri and Marina. And thank you for inviting me for this occasion. And thank you to the principals and vice principals of the Assumption College for conducting this webinar. I hope you're able to hear me.
Yes, sir. You're all audible.
All right. Thank you. So before I begin, I just want to provide you an information that United Nations has declared the coming decade as a decade dedicated to the ocean science for sustainable development. What it means is United Nations will be working towards more and more make people understand what ocean science is and how ocean science can affect people. So in this regard, I'm just providing some general talk today on how we look at the ocean from space. Let me just share my screen here. Okay. Great. I hope you can see the screen.
Yes, sir.
Okay, good. So I'm Korak Saha, so and I've been working since last 5-6 years with NOAA NCI. NCI is basically an organization called National Center for Environmental Information, and what we do is basically data production over the ocean and atmosphere. But I'm more involved with the oceanographic data set. And also we do archive the data, which is a huge job because the main thing is not only you produce the data, but somebody has to archive and provide it to public for general public usage. So I feel it's a very important job in a sense that you are not only contributing to science, but also you're contributing to your ecology and the people around you who will be using this data set that are generated by the scientific community. Okay, let's move on. I'll be talking a little bit, first few slides about what remote sensing is and how we accomplish that over ocean. So remote sensing is something that it's a technology that gathers information or data without actually physically touching the object. So if you say this is a wrong definition, this is probably the right definition where you actually use a non-touch sensor to measure the temperature. Of course, it makes sense because you want to study active volcano, let's say, and you won't risk just going there and studying the volcano. So the best way to do that probably will be using remote sensing techniques, which can be done through using flying an airplane or a drone or even a sensor in a satellite. What remote sensing all does is, this is very basic definition, probably for people who are in undergrads, that you have a source of light, and that source of light, when the light falls on an object, you have a sensor to sense that object, basically. Beginning of the 20th century, the pioneers of the remote sensing were actually these pigeons. I was looking for this talk, some of the historic elements, and I was very fascinated with this story. That's why I'm presenting this slide. It was about a pharmacist or a chemist in Germany called Julius Gustav Neubronner, who used to deliver his medicines using these pigeons. And he came out with an idea of, why not we just put small cameras on these pigeons and let them fly and take some pictures. And this was one of the probably first remotely taking pictures from the sky on Earth. This is what we are showing here are some of the pictures of over the pigeons flying over Frankfurt. Okay, so what basically we are doing when we are observing the ocean is you have a source of light, which is basically an electromagnetic wave, and it varies from different spectrum. You can see it can be invisible, it can be infrared, UV, or even going beyond the microwaves. And when these electromagnetic waves, they pass through the atmosphere, they interact with them. Because there are gases in the atmosphere, some of them, they scatter these waves, some of them absorb these waves, and whatever is left actually passes through it and interacts with the ocean. And there, other kind of interactions can take place, which can be due to the roughness of the ocean. It can be due to the salt over the ocean. So all these interactions we have to take care before we actually study or we actually remote sensing, do a remote sensing over ocean. So for an oceanographer like me, I don't want to have the noise that's coming from this intervening objects like atmosphere or the near surface, whatever we have over the ocean. So we have to figure out how to remove that part, and then only you can target the ocean. And this is interesting because when I was doing my PhD, I was doing the other way around. I was studying the atmosphere, so I couldn't throw it out. So what I had to do was I had to throw the ocean. So I had to see how the interactions over the surface is, and I remove that surface, and then I can see the atmosphere clearly. So it's in plain words, this is as easy as it can get. Like you have to understand how these electromagnetic waves basically interacts, and what information you can gather from these interactions. Okay, moving on. The example that I showed in previous slide was basically a passive remote sensing, where you have a known source of light, which is, in our case, is sun, and then the light that falls on the surface, and you basically get back or reflected or scattered whatever scattered emissions, and you sense them. That's a passive remote sensing. You can have an active remote sensing as well, when you have the right side of the cartoon is showing an active remote sensing, where you use a light source or a radio wave source on the flying object or the satellite, and it sends those in pulses or in waves, and whatever emits back is your signal to measure. So that's an active remote sensing. Okay, this is how crowded we are right now. So it's probably a couple of years back taken slide, so number has increased. I can assure you that. So we are observing our Earth from all the different sides, and it's very crowded. So the most important thing is how we are using this data set, because just observing the ocean is not enough. You have to connect it with everybody, with people, their life, the people who are dependent on oceans, and all of us, how it affects us. So another thing is why satellites, basically. There are different ways of measuring all these geophysical parameters over ocean. We call them in situ measurements. You have ships, you have buoys, you have Argo floats, you have moorings, you have sail drones. um, they're technologically very superior. So why don't we just use them? Why do we need satellite? Is because the ocean is very vast, and most of this data set, the in situ data set, are mostly sparse. So if you see this, the map which I'm showing just now, it's just a day of data, let's say, and it's not covering the whole Earth. So there are data gaps because you don't have enough in situ measurements. And even if you have, they're sometimes not continuous. Sometimes they may have maintenance errors or any kind of other errors in the system. They are not managed in a regular basis because once you deploy them, you may not be able to maintain them for a longer period, or you may have to go and retrieve them. So it's a very time-consuming process, and you don't get you have a lot of data gap when you use just the in situ data. So satellite comes handy because it's observing day and night, and it's providing you a uniform sampling. However, having said that, in situ data are very helpful because, first of all, they actually help us to retrieve any kind of geophysical parameter from the satellite data using different algorithms. So in situ data is very useful to develop such satellite retrieval algorithm. They are also important for data filling because you can have gaps due to satellite data as well. So you actually blend both the satellite and the in situ data set to have a nearly gap-filled data set. They are very important around the coastal regions, the in situ data, because I would say the in situ data is much more accurate in the coastal regions as compared to the satellite data because of the satellite footprint sometimes can have an ambiguity around the coastal area where you have both the land and ocean in the same pixel. They're also important for different under ocean or deep ocean observations. So yes, satellite data is important, but the in situ data is important as well. So here I'm just showing you two examples. One is a polar satellite and other is a geostationary satellite on your right. And you can still see some of the data gaps there. So in situ data comes very handy to fill those data gaps as well. This is an example of how the in situ data, when it blends with the satellite data, looks like. And you practically see a gap-free data set throughout the world, throughout the year. So these kind of data sets are very helpful these days because they are known as the level 4 data sets. May not be very accurate on on the grid size wise, or they are not, may not be or they may not be readily available in that way, but the thing is they cover the whole Earth and they're very useful in that sense. The first figure that I'm showing here is on your top left is a sea height anomaly, which basically measures the swelling of the ocean, which is useful for all the ocean and height anomaly studies. On the middle panel, I'm showing a blended sea winds, and there is also a sea surface temperature below there. So, and on your right, you have the sea surface salinity and ocean colors. So all these data sets are available online through our NOAA websites, and some of the data sets are also from NASA. But all this information is very useful to understand or to study the ocean. So these are different geophysical parameters that you can actually observe. This is another example of using the in situ data to validate the satellite data, which is important because once you have your satellite observation, you should have enough. I mean, it should be validated because you don't know how true your observation is. So you consider your in situ data as a true data set, and then you compare it with the satellite data, which is shown here on your on the left side figure. But this is a 1 year of matchup observation. Like you match the satellite and the in situ data set. That's why you have so much of data set. But this is like a 1 year of matchup of very good data set. So you can see that although in situ data is there, but it's not enough because for having that map, you are collecting almost a year of data set. So, but it is helpful in validation. If you see the time series plot that I've shown here, it basically shows that your satellite data is within the error bar that is shown with the dotted line. What it says is about your product or your satellite observed quantity parameter, which in this case is the sea surface temperature, that this is the value of your sea surface temperature, and this is the error of this value. How it helps? It does, because knowing an error of your observation is very important. It will be important for all the applications that this data set will be useful, because if you know your error, then you can figure out how much far you're from the true value. And you can visit this paper that was recently published, which basically provides us what is the error, or how to calculate the error in the satellite, any satellite observation in any of the geophysical parameters, using a very simple technique or comparison with in situ data set. Okay, I'll move on to some of the story maps, considering that what is more important for me is the fact that how this data set is useful to people, how it affects, how observing the ocean affects, or how NOAA affects different applications that we see. One of the examples I would show here is one of the sea surface temperature product, which supports the marine heat wave research that is done here at US. So what they do is basically use the sea surface temperature, a climatological data set, and figure out where these heat waves over the oceans they are observed, because these heat waves are very important, and it can displace the habitat of different marine organisms like sea turtles, whales, or even fishes, which is important because you need to know where your habitat, where the marine habitat is, and it can dramatically affect these habitats and their movement. Another story I would like to put here is about the coral reefs. Now, coral reefs are basically there's structures which are present throughout the world, mostly in some of the coastal areas in near to the equator region. They basically are very colorful, beautiful structures just below the surface of the ocean, and basically what they do is they're a huge provider of shelters for almost like quarter of the marine species. They live in these coral reefs, and they're very important for the the biology of the ocean. These marine animals, they live in and around these coral reefs. They also provide, they're the very primary factor in the food chain in the ocean. So they provide food to the first or second tropic of the level. They regulate the acidity of the ocean. They also act as natural, sea walls, because they don't allow the waves to build up, so that the waves don't come and wash away your beaches. So they actually maintain a lot of the best beaches in the world. So they are at danger right now, because what we are seeing right now is, if you see the middle picture here, the left side shows a very healthy coral, which has a lot of phytoplanktons and algae sitting on it, and it's almost living. So it is supporting the ocean biome. On the right side, you're seeing is basically bleached coral reef. What bleached coral reef means is, due to sudden shock in the temperature, or sudden rise in the temperature in the ocean, the coral reef decides to throw away its microorganisms that dwells on it, and once it does that, it actually kills, or you can say it's no longer supports the biome, or the microorganisms, or the fishes, or other small marine species that were dependent on it. So it's kind of, we are losing a lot of corals in our throughout the world, and it's because of, it's one of the effects that we are seeing due to the long-term climate change. So NOAA is specifically working on determining the temperature changes, or the bleaching that is happening because of these temperature changes, or due to this stress that these coral reefs are they are in. So here there are some examples of the different kind of data set that is provided to save these coral reefs, or to understand how or where this bleaching can occur. And it's very important even for the fishing industry. It's important for the tourism industry, and a huge amount of economy is attached to it. Okay, this is another example of how ocean observation, or the satellite observation over ocean is helping. 2020 so far has been named as the one of the highest years of recorded storms. There are probably around 25 storms so far, which is unusual, because I think it only happened once, that we ran out of all the names that are provided to these storms, and it was in 2005. So this year we are still in the middle of October, and we still have like a month and a half to go, where you can see more and more storms, and all these observations from ocean or over the ocean actually are helping to provide the forecast community with the data that is required for forecasting these storms. So it's important to have an observation like this. This is something also very near to my heart. It's about the oil spill that is happening because of the different oil fields in and around the coastal or near coastal areas, and it's it's a huge problem, because we have seen it in 2010 Deepwater Horizon spill, where a huge amount of oil was spilled there, and it was a devastating effect on the marine life there, and the repercussions of those effects are even seen today. So NOAA is basically developed a restore program where we are using different satellite and in situ measurements and try to assess how the oil spill has impacted the marine animals and the ecology in and around those areas. There is also a website which actually provides this information in a daily basis, like what is the effect of this oil spill on day to day. And I feel this is very important because this is not only affecting the marine animals, it's also affecting the people who are dependent on that on those coastal areas for any purpose, ecologically or even for economically. This is the example of the oil spill areas where the blue dots are basically the oil, and this shows that how grave the situation is, and how important it is to observe the ocean and keep observing it continuously, so that you don't have these kind of spills, or you can respond to these kind of spills in future. And I mean, it's not only future, it's actually present, because every day these kind of spills are happening, and you can go and check in this website and see how these oil spills are happening every day. And there are some other stories as well. There are algal blooms, which are basically the affecting the fisheries industries. It affects the socioeconomic way. In a socioeconomic way, there are things that affects the commercial fishing as well, that NOAA helps with. Also, not only the ocean, in and around the ocean, there are a lot of marshy areas that we study, and it helps to study those areas not only for their productivity, also for the sea level rise to those areas. And there are other different stories that are attached. I mean, you can go and search in our websites, and you will find a lot of applications that over the ocean that NOAA works in. Okay, so let's look into the future, especially where I work. What we do, as I said, that one of the major job is to archive this data set, because you have to provide this data set to people. Just getting or gathering the data and keeping it to yourself it's not going to work, because you have to make this data useful to people for their usage. So one of the major thing is how to what we do is, like, we archive this data set, we store this data set, and then we provide this data set. Now, so far, if you see this graph on the left side, it actually projects to 2030 that we will be, by 2030, having almost like 18 petabytes of data set, which is 10 raised to the power 15, I guess. Yeah. And by 2025, it says it's 10 petabytes. But I think, if I'm not wrong, this is a couple of years back slide, what I know is, like, we have already crossed the 2020 limit that was around, like, I think below 10 petabytes, but we have almost reached to that level. So it's a huge amount of data set. And to store that data set, I mean, we are so far using disk spaces, or there are different big servers that we have to serve this data set. But going in future, I don't think, or we don't think that it's possible to hold that much of data set without help from outside. So what we have been doing is, like, collaborating with the private partners like Amazon, Google, Microsoft, and IBM, and developing this cloud consortium. So in going in future, the data set is going to be sitting on most of these cloud in the cloud, and this cloud from the cloud, people will be able to download this data readily and easily. The work has already started, and there's a list of data set that I provided here, and you can actually figure out what data set we already have there. There are hundreds of data set already has been transferred to the cloud. Now the data will be still free, although it's going to let's say a private cloud or even like a cloud consortium. The data will still be free because it's a NOAA policy, because these data set are archived using taxpayers' money. So it has to be free, and it will be free. Also, as I mentioned about the cloud services, one of the most important thing that we have been able to achieve recently was not only take the data to the cloud, also take your computational to the computational technique or your computational satellite of the satellite data to the cloud. So and it helps because it has reduced a lot of our disk usage and a lot of our processing time, because the faster your processing time is, the faster you're able to provide that data set to the people. And the comparison is enormous. If you see the first snapshot that I have shown here, this was a study done by an institute in North Carolina for climate studies, and it basically shows this study was done on Amazon Web Server, and it basically shows that they use 20 years of data set processing, which the usual time on in-house computers cluster was like 1,000 hours and was cost like $84,000 US. They ended up doing the whole work in 20 hours on Amazon Web Services, and the cost was like almost, I would say, 1/8 of the price. So what we are understanding is it's no longer useful to have big servers and maintain your or do your computational in-house in these big clusters and servers or virtual machines. It's better to move to cloud. So in that process, we also, like, I was involved with one of the experiment that we did with our product, a sea surface temperature product, and we actually could save a lot of time. Like, we did a 35 years of processing in just 20 days, which used to take like 6 months. Also, cloud services, they provide support of AI, which is artificial intelligence, and you could do your data analysis, which used to be done in 2 hours in our local machines. It was done in 5 seconds. So we are using both the technology and the efficiency of the cloud services for our computational purpose. Here's one of the example of an AI-based application over NOAA, because AI and machine learning has been a lot talked about these days. And in this very interesting study, what they have been doing is there are some beluga whales, which are a type of endangered species, and they have been studying these the sound that you receive from these whales, and try to identify their locations all around the Atlantic Ocean. So this was one of the first studies that were started at NOAA using the AI technique. And this is another something probably will interest, because this study was actually done with the government of India, and this was done over the Google Cloud environment. And what it does is basically using AI, it improves the or basically it does a flood forecasting, and it provides
the data to the public as soon as possible using an app. And what we see in this, and I've seen the results of this experiment, and it's really good to see that how AI has improved not only the resolution of the data set, but also the time resolution of the data set, where you are doing these huge calculations and retrieving this information on cloud in fraction of seconds. So this is with this, I would say that, we are moving in future towards the more artificial intelligence and machine learning process. The benefits are enormous. You have a good data quality control system. You can automate your data processing. It's important to have a good data assimilation. You will have a better and faster prediction of the forecasts, which is useful. You'll have applications in fisheries, in weather forecasting, in different ocean, parameter measurements and predictions and hazard detection things. We already started working on a lot of things, and you will see that the most of the AI techniques or machine learning techniques are nowadays used in satellite-based metrology or satellite-based oceanographical studies. So, yeah, it's important, and it's going to be very useful in future. But I will give you a word of caution, just to end this talk, that yes, AI is important, but it can provide you some bad results as well. So you have to be really careful while using AI or machine learning as we move in future. So yeah, with that, I would like to thank all of you. You can also go to this source of another source of data visualization from NASA. It's a very good website, and you can actually see online in a real time or near real time how different oceanographic and other data set looks like. Okay, I'd be happy to take questions if there are any.
Thank you, sir. Now the session is open for discussion. Participants, please post your questions in the chat box. Is there any questions? You can drop your questions in the chat box. Sir will be happy to answer.
Yeah, no questions means either I was too good or I couldn't reach out to you. But yeah, I will welcome any questions.
Okay,
Yes.
there is one request, I think. Like to send slides that you use for the presentation.
Yes, sure. I'll share this slide with the organizers, and probably they can send it to all of you.
Okay, some questions, please. We have some student participants also. You will be eager to know what are the research going on there.
Saha, you were explaining about ocean color, right? So for the
Yes.
information of all, can you say a little about what ocean color means basically? Students may not be knowing much about it. Just as slightly about ocean color.
Okay, so when we say ocean color, it's basically what we are talking about is when you're observing the surface of the ocean for different kind of biological structures like phytoplanktons or algae, and because they have chlorophyll, because they generate their own food, so they have chlorophyll, and so that's why when you look at them from the ocean, from the top, you see as them very colorful, objects. So they're basically what you're observing are chlorophyll measurement. That's what we call ocean color.
Okay, there is one question. How can I get true ground data?
Oh, how can I get the truth
True.
ground data? Okay. Yeah, I mean, I have provided that information in the slide though, but there are different ways. If you can get into any of the NOAA websites, and if you search for the in situ data set, you will be able to get any of the data set, which is probably, I think, is the ground data you mean. I mean, the ocean surface data. But about truth, it's kind of, you may use it as a true data set, but you should keep in your mind always that there are some errors associated with that data set as well. And most of the data providers of this ground data set do provide this information, that how much is error in your ground observation is. So yes, it's true data, but it will definitely have some associated errors in them.
Any questions? Sir, can you tell some of the research opportunities in your institute, in your university?
Yes, so University of Maryland has this department called ESSEC, which is Earth Science Department here, and they do a lot of recruitment on postdoctoral level mostly, although there are some undergrad and grad level of work that people do, but that's more related to academics. But on research basis, they are mostly postdoc work, and I mean, I can put in the chat box the link of this of our institute or our department, and you will be able to go through each and every the field that ESSEC is involved with. It has to do with all the starting from ocean to atmosphere to the land studies, and also planetary studies as well. So I would say there are a lot of opportunities, and if you are planning to do your PhD over here, you probably have to go through the usual process of getting to an university through different exams, which I'm not much aware of that. But if you are coming here as a postdoc, like after your PhD, there definitely you should go and check the website for different different positions that are available. And I mean, they usually come up. A lot of positions are definitely available.
Thank you, sir. Any other questions? Okay, if there are no more questions, Gayatri, please take over the session.
Once again, thank you so much, sir, for your interesting and excellent topic of discussion, and we had a great time listening to you. Now, we move on to the end of discussion. I welcome our faculty coordinator, Dr. Sharon Thomas, for the vote of thanks.
Thank you, Gayatri. Am I audible?
Yes.
Good evening, everyone. Respected Principal, Reverend Sister Charagusumam CMC, Vice Principal, Reverend Father Dr. Thomas Partara, Dr. Anita Jose, our resource person, Dr. Korak Saha, Head of the Department, Dr. Marina Lucius, Association Secretary, Ms. Asmi Mary Sibi, distinguished participants, and my dear colleagues. I'm very honored to express our deep sense of gratitude to all those who supported us in one way or the other to make this World Space Week celebration 2020 a resounding success. First of all, let me thank God Almighty for showering His blessings and grace in every walks of our life. Let me express our heartfelt thanks to our principal, Reverend Sister Charagusumam CMC, who motivated us in executing this event successfully. It's my pleasure to thank our vice principals, Reverend Father Dr. Thomas Joseph Paratara and Dr. Anita Jose, for giving us valuable suggestions and guidance. Now, it's my privilege to render our sincere and heartfelt thanks to the resource person Dr. Korak Saha, Assistant Research Scientist, NOAA, Nestis, NCEI, University of Maryland, USA, for gracing today's webinar with an enlightening and fruitful lecture. He has given an overview on some of the areas such as remote sensing, applications, oceanographic studies, and how satellites helps in data collection, etc. I am quite sure that we are all able to explore the research works going on in this area to some extent. On behalf of the Department of Physics and all gathered here, we express our deep sense of gratitude to you, sir. It's my privilege to propose vote of thanks and acknowledge the contributions of those who worked really hard to make this event happen. I extend my sincere thanks to our head of the department, Dr. Marina Aloysius, for being there as a strong pillar of love, motivation, guidance, support, care, and much more. Now, I would like to appreciate our Association Secretary, Ms. Asmi Mary Sibi, for her sincere and timely efforts for the success of the program. Also, thank you, Ms. Gayatri, for hosting the session. I would also like to thank the people who worked behind the scene to make this event happen. We have a YouTube live streaming of our program, and I express my wholehearted thanks to Ms. Anne-Marie Matthew for her technical support. With a deep sense of appreciation, I thank my colleagues Ms. Anne George for her efforts, Ms. Jocelyn Xavier, Dr. Jeslie Jacob, and Dr. Vidhu VK for all their valuable suggestions. No event can be a success with we teachers alone, so I extend a heartfelt appreciation to our dear students who are the heart and soul of our department. Finally, I take this opportunity to extend heartfelt thanks to all the participants, including faculty of various institutions, students not only from our college, but from other colleges too, and all our well-wishers who have turned up in such a great number. On behalf of the entire Assumption family, we thank you all for sparing your valuable time and enriching the session with your presence. We expect your support and participation in all our future endeavors. We are happy to inform that as part of the World Space Week celebration, our PG students are conducting an intercollegiate quiz competition for UG and PG students on 12th October, Monday at 3:30 p.m. The topic is related to space science, so we request all of you to share the link given in the chat box to your students and encourage them to participate. Once again, I thank you all for your cordial cooperation. Thank you.
Thank you, Miss. Thank you all for your great cooperation. We are extremely grateful to each and everyone who attended this webinar and made it a great success. Thank you all, and have a great evening.